Inequality and absolute value inequality, application part 3. From the last application problem, this was our graph. We wanted all the students to be sent home that had a temperature of 106 degrees, greater than 106 degrees Fahrenheit, and less than 96.6 degrees Fahrenheit. We got these numbers from the absolute value inequality, where we looked at temperatures of students, the difference of the temperatures of students that had to be greater than 2 degrees away from that average. I want to talk more about this average and this tolerance. Remember, I said that the school will tolerate a 2 degree. So this number out here that was giving our range above or below, the number of units above or below our average, is called the tolerance. And the number that we're looking at, kind of you can think of it as the new zero, is the average. The average is in the exact middle, the midpoint, the mid-coordinate, however you want to think of it, between our extreme values. Now the solution to this we got was a range. The temperature of the students had to be less than 96.6 or greater than 100.6. Now, what I want to talk about in this video is how we can get from the range back to the absolute value inequality. Now, you might ask, okay, if you're given a range and you're given the answer, why are you going back to make it more complicated? The reason why is we want to become more flexible with our mathematics. We want to know exactly why things work the way that they work. And one thing that we can do to see how things work is look at the parts and see how it fits back together again. So, I have a mini problem for you before we go on to the actual word problem. Let's say that we want a range of numbers. And we want to, instead of explain this as a range of numbers, we want to explain it as an absolute value inequality. First, let's get an understanding of what the graph looks like. Sometimes it helps to visualize this. That's the graph. Now, notice, 0 is not exactly in the middle of these numbers. We can't use the distance to 0 to explain the absolute value. Instead, we want to talk about the average. Remember I said the average is like the midpoint? We want a distance that is exactly in the middle of both of these numbers. And you find that by finding the average of the two numbers. Adding them up, dividing by 2. This number is -3. Now, remember before I talked about in the last problem that 2 degree tolerance of the temperature? Well, we can also have a tolerance here, and the tolerance is the distance between the average and an extreme. An extreme is any value that is on the outside or the boundary of our range. So in order to find the distance, we need to take the difference. Now usually what we would do is we would take the absolute value of the difference of both numbers. But in this case, we're just going to take our extreme, that if we take the difference, it's a positive value. Now, it's to be expected that since we have a tolerance now of 9 between -3, the average, and 6, we're also going to have a tolerance of 9 between -3 and -12. Now, our absolute value inequality. Every number we want has to have a difference from the average that is 9 units away. Let me say that in a little bit easier. Any number that has a distance from our average that is within the tolerance. In this case, x plus 3, absolute value of x plus 3 has to be less than or equal to 9. Average, tolerance. We're going to use a similar method to solve this problem. We want to write an absolute value inequality that shows the range of fans for the concert. A concert arena is hoping to have a minimum of 10,000 fans and a maximum of 15,000 fans. Now, of course, this is an absolute value application, therefore we should define the variable as the number of fans at the concert. This is our range. We're first going to take the average to find that midpoint. Then we're going to take the difference of our upper bound and the average. And that will give us the tolerance. Now, when we're looking at the average and the tolerance, that helps us set up our absolute value inequality. Remember, we want the number of fans and the average number of fans to be in a distance that is less than the tolerance. Now, in the book, you just have to write the absolute value inequality after you've found the average and the tolerance. I'm just going to check this to make sure that we get the same range and that it makes sense. We could check it by solving it, but I just want to think of it conceptually. Basically, what I'm saying here is that we have an average of 12,500 fans. If we take a tolerance of 2,500 on either side, then we should get the value of 10,500, 10,000 on this side and 15,000 on this side. And that does work out. 12,500 plus 2,500 is 15,000, and 12,500 minus 2,500 is 10,000. So here we have the graph of the range, and the range shown as an absolute value inequality.